Okay, it looks like the other video stopped right about here. So I think we were right about here. Remember, when you take the square root of a perfect square, you get what's underneath the radical. So I get x minus 4 plus or minus the square root of 3. So this becomes x equals 4 plus or minus the square root of 3. So these are two separate equations that we have to solve, and you need a calculator. So 4 plus the square root of 3 equals 5.732. 4 minus the square root of 3 is 2.268. Now, we should write those down in an ordered pair format. So x-intercept, where it intersects the x-axis, written in ordered pair form. For the y-intercept, all you have to do is take your equation, plug a 0 in for x. So 0 minus 4 is negative 4 squared, which is negative, and out front we have a negative, so this becomes negative 16 plus 3 is y equals negative 13. So that's the y-intercept. So we should write it out as an ordered pair. Now what we do is we grab the y-intercept, the two x-intercepts, and the vertex. We plot those points, then we draw a smooth curve. The other option is just to graph the equation in decimals. So now, hopefully we have the hang of it, and we're going to work through a couple more examples. Here's this next equation. Notice that the sign of a is negative, so it should open up. Here's the standard form of the equation. So notice we're given x plus a number. Well, the standard form is x minus h. So we need to rewrite the plus as minus a negative. So then we clearly identify h as negative 1. K is 2. So our vertice is negative 1 and 2. And so like we said, since a is negative, it's a maximum. So the max is going to occur at 2, whatever the k value is in the vertice. To find the x-intercepts, again, simply let y equal 0 and solve for x. So like before, we're going to add 3x plus 1 squared to both sides to get the squared term on the left. I'm going to divide through by 3 so that I can get the squared term by itself. Then I take the square root. So on the left, I am left with what's under the square root, which is x plus 1, and on the right, plus or minus the square root of 2 over 3. Now to get x by itself, I subtract 1 from both sides, and I have these two equations, which again, you're going to need a calculator. So minus 1 plus the square root of 2/3 is minus 1.816, and minus 1 minus the square root of 2/3 is negative 0.18. Actually, I think I might have got these mixed up. I think this one goes with this one, and this one goes with this one. And then you write them as an ordered pair. For y-intercept, you let the x equal 0. So taking our equation, plug a x in for 0, I get negative 3 times 1 squared is 1 plus 2 is negative 3 plus 2 is negative 1. So that is where the y-intercept occurs. So now what we're going to do is plot our points. We have our vertice at 0, negative 1. And then we have our x-intercepts, and we have our y-intercept as well. Finally, on to the last equation. 2x minus 1 squared minus 3. This one's going to have a minimum because a is greater than 0. Here's our equation in standard form. Notice that we have x minus h, x minus 1, so h is 1. But over here we have a minus 3. Really, a minus 3 can be rewritten as plus negative 3. So k is negative 3. So this is our vertice. Our minimum's always going to occur at the vertice, so that's the y value, so that would be negative 3. X-intercepts, let y equal 0, solve for x. So we're plugging this in, add 3 to both sides. Like before, we got to get the squared term by itself, so we're going to divide through by 2. And I'm actually just going to simplify this to 1.5.